So if you checked out our one-step equations playlist, you're very familiar with this inverse operation, the additive inverse. We use opposites to create zeros to allow us to isolate a variable. In this case, we want to isolate the variable x. So what we're going to do is we're going to use -7 or subtraction of 7, which is the opposite of +7, to make a 0. We're going to do the same thing on the other side of our inequality here. We now have x plus or minus 0, which we can just call x. We're going to say that is less than or equal to 3. If we read this originally, x plus 7 is less than or equal to 10. We take 7 away from both sides. Now x is less than or equal to 3. This is our solution. It's not just one solution, it's a whole set of solutions. Our point in question, we have a solid line equal to, so 1, 2, 3, we're going to use a solid dot because 3 is part of our solution. But every number less than 3 is also part of our solution. So 2, 1, 0, any of the negative numbers all make this equation true. If I put 0 in here for x, 0 plus 7 is less than 10. If we use +1, 1 plus 7 is 8, 8 is less than or equal to 10, so on and so forth. If we come over to this side, we want to create a 0 here by adding 4. We'll do the same thing on this side of our inequality. We now have x minus 0, or simply x, is greater than or equal to -4. -8 plus 4 is -4. This time x is greater. We have the larger side of our symbol here. So our point in question is -4. It can be greater than or equal. So we'll make a solid dot here. And greater is to the right. Everything greater than or equal to -4 is part of our solution set. So mentally I'll pick a number over here. Like maybe I'll pick -2. And I'll say -2 minus 4 is -6. That is greater than -8. Or I may pick a positive number like +3 and say +3 minus 4 is -1, which is greater than -8. We see our solution here symbolically. We also represent it visually on a number line, going to the right for greater or to the left if it's less than. For these inequalities, we have slightly larger quantities, larger values, and so we're going to have to scale our number lines differently to represent our set of solutions. We're going to use our same additive inverse to create the additive identity of 0 to isolate our variable x in this case, which is why we have horizontal x-axes here to work with. To make a 0 here, if 40 is being subtracted, we're going to add 40 and do the same thing over here. We now have x plus or minus 0 must be greater than or equal to -10 plus 40 is 30. This is our set of solutions. X is greater than or equal to +30. So where is 30 here? We have 1, 2, 3, 4, 5 spaces, which makes 50. Same thing here. 1, 2, 3, 4, 5 backwards makes -50. That means each one of these spaces must be worth 10 units. So 10, 20, 30 is right here. It's equal to or greater than. So we're going to put a solid dot here. And all of our x values must be greater than 30. That's going to the right. So here we go. 30, 31, 32, 40, 50. Let's see, if we have 50 minus 40, that gives us +10, which is greater than -10. It's always good to take a couple of values here from your solution set, mentally plug them back into your expression to make sure it makes the inequality true. Let's come over to the other side. We're going to read it out. -27 plus x is greater than or equal to -36. To make a 0 here, same additive inverse. Please don't get confused by the fact that they're just in a different order here. We're still going to add 27 to bring this back to 0. So now we have 0 plus x, which is just x, is greater than or equal to. Now, whenever you add integers like this, look at which sign has the greatest absolute value. I look at this and know my final answer is going to be negative because there are more negatives here than positive. -36 has a greater absolute value than +27. So I know I'm going to have negative something. When I subtract, it's a 9. negative 9 here. So x is greater than or equal to negative 9. Let's see what we're going by here. 1, 2, 3, 4, 5, 6 to make 30. That means these must be going by 5s. 1, 2, 3, 4, 5 to make negative 25. Sometimes the number line you're given doesn't give you an exact value you're looking for, so you have to estimate a little bit. Negative 9 is behind 0. We know we're going to use a solid dot because we have greater than or equal to. So again, 1, 2, 3, 4, 5 to make negative 25. That means each of these spaces must be worth 5 units, negative 5 units. 5, negative 10. If I cut this into 5 little pieces, negative 9 is going to be right about here. And my solution set is everything greater than x. Greater than, once again, is to the right. Everything over here. So in this case, an easy number to plug in would be 0. Negative 27 plus 0, is that greater than negative 36? Yes, it is. Negative 27, say, plus, I don't know, negative 5. That will give us negative 32, which is still greater than negative 36.